Hello, welcome to the last section of Unit 3, which is Lesson 8. Today we're going to be graphing in vertex forms. We're actually going to be graphing quadratics. We've been solving them, we've been factoring quadratics, all these different kinds of things, but now we're actually going to graph them on a coordinate grid. So there's a few things to remember. You guys did a lot of practice with graphing. You learned how to graph 3 different ways: standard form, vertex form, and then intercept form. Our main focus is vertex form, and it should seem really familiar because we did some graphing earlier this year that we're going to recognize some similarities. So remember that the general shape of a quadratic is that it can open up or down, and that's called a parabola. And then the point where the parabola turns left and right, that's called the vertex. That's either the minimum or the maximum point. This line that divides it in half is called the axis of symmetry because it splits it perfectly in half. And then this point where it crosses the y-axis, that's the y-intercept. Now there's several different ways to list the x-intercepts. That's one. We also know those, I'm just going to put x-int. Those are zeros because those are the points where x is 0. We also call them solutions or roots. Those are the 4 different names that we have for them. The x-intercepts, the zeros, solutions, or roots. They all mean the same thing. It's basically what would, when we're looking at a quadratic equation, what would make the whole thing equal to 0. So let's go down here. Now, here's the general equation for vertex form. Y equals a x minus h squared plus k. Now, the reason this looks so familiar, if you remember when we did absolute value, it was y equals a absolute value of x minus h plus k. So the only thing that's different is now we're using parentheses and it's squared rather than we had the 2 bars like that. So don't confuse these two. They are different, but there's a lot of similarities between the two. Because the a value still tells us if it opens up or down, or if it's wide or narrow. And then h is the horizontal shift, and this is again the opposite. So if it's a negative inside the equation, it's positive when we pull it out in the coordinate form. And then the k stays the same. All right? And remember that the parent function to this is y equals x squared, and that is centered at the origin, which is 0, 0. So we're going to be talking about like vertical shifts and horizontal shifts from this equation right here. This is that parent function, so that's where everything is derived from. So let's look at example 1 here. So graph the vertex form y equals 2x plus 3 squared minus 4. So the vertex comes from the h and the k. Since it's plus 3 inside the equation, it's negative 3 when we pull it out, but k stays the same. So it's negative 3, negative 4. So I'm going to go back 3, 1, 2, 3, down 1, 2, 3, 4. Here's my vertex. The a value is what's out front, so that's positive 2. That tells us it's going to open up. So this is going to be a minimum point because it's opening up. Okay, so if you remember, we use this table. You may have seen this before. What we do is we always use the same numbers. We use 0, 1, 2, and 3. And then we refer back to the parent function, which was this thing up here. So if I were to make an x and y table with 0, 1, 2, and 3, and if I plug those in for x each time, it's just squaring that number. So 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So these numbers should look really familiar. You've used these a lot in the past. So that's what we get here every single time. 0, 1, 4, because I got to square the x value, and 9. Now the a value is where you multiply the a, which in this case is 2, times y. So 0 times 2 is 0, 1 times 2 is 2, 2 times 4 is 8, and 2 times 9 is 18. Now that we have those numbers, that gives us our counting pattern, so we no longer need the third column. All right, so 0, 0 just means this is our first point. That goes for the vertex. 1, 2 means we go over 1, up 2, but then we also have the mirror image, which would be back 1, up 2. Then we go over 2, up 8. Oh, go back here. Don't know what happened there. Okay, let's go back to where we were. So 0, 0, first point, over 1, up 2, we had that. Right there, right there. Then we go over 2, up 8. Should be right there and right there. And then we could graph the 3 and the 18, but that's going to be off the grid. So we're actually good enough right there. If it's going to go way off the grid, don't even worry about it. You actually technically only need 3 points to graph a parabola. You need the vertex and then you need a point on either side. But it's just more accurate if we have more points. So just try to graph as many as possible. But if some of them go off, don't worry about them. The domain, there's no restrictions to a parabola. So if there's no restrictions, we can plug anything in for x. We're going to do that lovely r, which is all real numbers. Now the range is similar to the absolute value. It's either going to be y is greater than or equal to, or y is less than or equal to. In this case, the y value, which is k, is -4, and everything is at -4 or above. So it's going to be greater than or equal to -4. All right, let's keep going. Vertex, h and k, opposite of -2 is +2, and then k stays the same, so it's 2, 6. So over 2, up 1, 2, 3, 4, 5, 6, right there. The a value is this negative sign, which is -1. Okay, so we use the same values for x and y like the last one, 0, 1, 2, 3, and then we get 0, 1, 4, 9. But since the a value is -1, we need to multiply everything in the y column by -1. So we get 0, -1, -4, -9, and now we no longer need this column. Now, the reason we get negative numbers is because this is going to open down, which means we have a maximum point because everything's going to be below our vertex. So now we just follow the pattern. So 1, -1 is over 1, down 1. We got to do that on both sides. We go over 2, down 4. 1, 2, 3, 4 right there. And then we do that on the other side. And then over 3, down 9. Right there and right there. And since all of the points fit, you should graph them. Should have graphed them. Again, the domain is all real numbers. This time, though, the range is going down. So our highest point is the k value, which is +6, but everything is below it. So everything for y is less than or equal to 6. All right, one more example here. So let's go ahead and graph this. Vertex h and k, opposite of -3 is +3. K stays the same. The a value is 1/2. So we do want to be careful when we have a fraction for our a value, because we all love fractions. So we get 0, 1, 2, 3, 0, 1, 4, 9. Oh, since it's positive a value, it still opens up, which means we're going to have a minimum. Now the a value here, we need to take everything in the y column times 1/2. So we get 0. This one, it is okay to just do decimals if that helps. So you would get 0.5, you would get 2, and then you would get 4.5. I don't care about decimals for the graphing part because sometimes it actually is easier to think of these in decimals. Okay, and the domain, as you probably guessed, is all real numbers. It's always going to be all real numbers. Let's go ahead and graph this. So our vertex was over 3, down 2, and we're going up, but we don't need the y column, so we're going over 1. Excuse me, let me just mute this for a second. Okay, so over 1 up 1/2 is right there, but we got to do that on both sides. Over 2 up 2, right there and right there. And then over 3 up 4.5 is right there and right there. So this is wider than the parent function because our a value is less than 1. So this one up here was narrower, and it looks thinner than most of them. And then this one is the same because, remember, it's the absolute value of our a value. So since the absolute value of 1 and -1 is the same, we get the same like width for between points. Okay, now the range, our k value is -2. And then everything is above it, so it's greater than or equal to -2. Now this is a little bit different. How does this function compare to the parent function? Well, it's wider for 1, which we just stated. The other thing is we have to think about how did the vertex change? So it has a vertical shift of -2 because it went down 2 points from the origin, which is our usual vertex. So vertical shift of -2, or you can just say down 2. And then it has a horizontal shift of plus +3, or horizontal shift to the right, I probably should say, because here's the origin, so we went over 3, down 2. So if you're just trying to explain that, you can say over 3, to the right 3, down 2. Or if you're trying to be technical, which if you take pre-calc, calculus, any of those more advanced class, they will want you to specify like vertical shift, horizontal shift, and so forth. So, okay, go ahead.